Welcome back. In today's video, we would like to talk about box plots. They are also known as box and whisper plots. Here is an example of our box plot here. And now we are going to discuss different parts of a box plot before we can go further and discuss the details of how to plot them. In order to know what box plot is, we need to mention that they are powerful data visualization tools that show the distribution, spread, and outliers of numerical data. For example, they summarize the key statistics such as the minimum here and the third quartile, and the maximum here. Okay? And a box plot consists of boxes that represent the interquartile range. So here is the interquartile range, for example, and 50% of our data exists there. Okay. And then we are having the median, which means that this point is the middle point of our data. We call it Q2 as well. So it means that 50% of our data is below this median and 50% of our data is above this median. Okay. Then we are having the lower whisker, and upper whisker. We also know them as mean and max. But how can we calculate the lower whisker and upper whisker? In order to calculate them, there is a formula. We are going to have the Q1 here, first quartile, and second quartile, and the third quartile, okay, in a box plot. So the first quartile is here, and this is the third quartile. Here, when we are having the difference of the Q3, and Q1, which is here, okay, we are going to calculate the interquartile range. When we are having Q3 minus Q1, we are having the interquartile range. Okay, this is the number that we want. And in order to calculate the lower whisker and the upper whisker, we need this number because the formula for lower whisker and upper whisker is the following. So Q1, okay, Q1 minus 1.5 multiplied by IQR or interquartile range. So this number is calculated based on Q3 minus Q1 and it is multiplied by 1.5. And from that, we are reducing the Q1, which is this number, okay, first quartile. And then this is the output of this formula will decide the lower whisker, okay, excluding outliers. We're going to discuss outliers as well. And when we are having this formula, we are going to calculate the upper whisker, meaning that we are going to have Q3, which is here, plus 1.5 multiplied by interquartile range. The output will give us the value of the upper whisker. This way, we are calculating the lower whisker and upper whisker. Okay? So now let me review. So we are having the Q1 first quartile. This means that 25% of our data is below this Q1. Q2, which is the median, means that the 50% of the data is below and 50% is upper. Q3 means that third quartile, which is our third quartile, means that 75% of the data is below this Q3. Okay, 75% is below, and the remaining 25% is above this. And this is how we can have the Q1, Q2, and Q3. We also discussed the interquartile range, which is Q3 minus Q1. It's going to give us this part. And finally, let's talk about outliers. So an outlier is a data point that is unusually far from the data set, okay? Based on the, for example, 1.5 multiplied by interquartile range. Okay, so this rule gives us the upper whisker, and the lower whisker. Anything that, and we are having the lower whisker here and upper whisker here. So anything that falls below the lower whisker is our outlier. And anything that is above this upper whisker is again our outlier. So anything that is unusually far from the dataset. This way we are going to understand the outliers. So it was a good introduction to box plots. Now we are going to continue in the following videos having some coding exercises of how we can plot box plots and deal with different parts of this. To review, we are having the Q1, which has the 25% of the data is below it. Q2, 50% is below it. Q3, 70% is below it. Then, based on Q3 minus Q1, we calculate the interquartile range, and we use that to calculate lower whisker and upper whisker. Anything that is lower than our lower whisker or above our upper whisker is our outlier. In the following videos, we are going to dive deeper into box plots. Thank you for watching.